Alright, hi everyone. So I want to prove two properties that matrix multiplication has, and these properties may seem pretty boring to you. So I'm going to work through the proofs. If you're interested in that, that's great. I don't think these are the most interesting proofs we're going to do in this class, but I'd like you to stick around till later in the video when we do an application, because it's actually pretty cool what we can do with these properties. So the first property says, if I want to take a matrix A and multiply it by the sum of two vectors, what I can do is I can just apply it to the first vector, get an answer, and then apply it to the second vector, get an answer, and then add them together. Okay? And that may look like kind of, okay, well, no big deal. And so let's see why that's true. So I'm doing this in the 3x3 case below. And so we've got our two possibilities. So on the one hand, we have applying it to the vectors u and v individually and then adding. So here's our matrix times the vector u. Here's the matrix times the vector v. And we're going to add those results together. So let's just do that calculation and see what we get. So in the first part, I guess we're going to get u1 times the first vector a1 plus u2 times the second vector a2 plus u3 times the third vector a3. Okay, so that's this first part here we just finished. And now I'm going to do the same thing with the piece on the right. Okay, so if I do it on the right, everything's exactly the same, except instead of u's, we've got v's. And now, of course, what I'm going to do is I'm gonna look at that, and I'm going to say, oh, well, that's, I have some common terms here. I have a vector a1. I don't know what it is because I don't know what the numbers are, but I see on one hand it's being multiplied by u1, and the other hand it's being multiplied by a1. Right? And so what I could do is I could say, well, that's the same as u1 plus v1 times that first vector. That takes care of those two terms. And then, you can see that the same sort of thing happens with the second vector. That's u2 plus v2. Zoom in a little bit. This is going to be u3 plus v3 times the third vector. And so if I just kind of allow for a little bit more space, we have a nice simplification of that matrix product. And now let's do it the other way, right? What if we add the two vectors together first? Well, if we add the two vectors together first, then what we're going to get is our matrix times u1 plus v1, u2 plus v2, u3 plus v3. And if we work that out, well, we're going to get the first entry times the first vector plus the second entry times the second vector plus the third entry times the third vector. And now, if I look up what I got before, that's exactly the same as what I had above. And so what I've shown, if I zoom out, is I've just shown that a times u plus a times v is the same as a times u plus v. Okay. And that's pretty nice. We're going to see this is something called a linearity property of matrix multiplication. And the other property I want to show today is that if I take a matrix and I multiply it by a scalar, this is some scalar, times u, then that's going to be the same as that scalar times the matrix product. In other words, I can pull that scalar outside of our product. Okay? And again, this probably doesn't seem that interesting. I'll show you why in a moment, why you might care. But for the moment, we can just kind of do the same sort of calculation before, Let's calculate the left-hand side. Right, so again, we're doing it for a 3 by 3 matrix. And what I'm going to do is I'm just going to simplify this inside. If I have C times a vector, well, that's just going to be C times U1, C times U2, C times U3. And then when I simplify that product, it's just going to be a combination of these three vectors. It's going to be the first one, C times U1, the second entry, C times U2, and then the third entry, C times U3. Right? So just some calculation. Again, what we're doing is we're doing the first entry times the first vector, plus the second entry times the second vector, then the third entry times the third vector. And now let's do it the other side, right? We wanted to show that that was the same as first computing the matrix product and then multiplying by C. Well, let's do that. So we wanted to show that the matrix product times C should give us the same answer. So I've written that out here, C times this matrix product. And again, if I work it through, I just get C times this big sum. So it's going to be U1 times the first column, U2 times the second column, plus U3 times the third column. And now when I multiply that sum by that constant, it's just going to go and distribute to those three terms. And if we zoom out a little bit, we will see that the answer we just got was exactly the same as what we had before. So these proofs are just calculations. They're kind of tedious, a lot of writing. Maybe you don't find them so enlightening. That's okay. That's okay. But I want to try and convince you that these properties are really, really important. And I want to show you maybe a cool application. So suppose that you were solving a system of equations. Suppose you were solving this system down here. You wanted to solve you had some matrix, maybe it had a bunch of entries, and you were trying to solve A times X equals 0. And suppose that you had already found two solutions. Suppose you had already found that this was a solution and this was a solution. Well, now I claim that this vector down here also has to be a solution to that same equation. And maybe I want you to pause the video for a second and see if you can see a relationship between this vector down at the bottom and the ones on top. Okay. So the relation I see is that it's the sum of those two vectors. Right? And so what I can say is well, what happens if I multiply A times this vector? 5, 3, negative 3, 4. Well, that happens to be the sum of these two vectors. So that's A times that vector plus this other vector, right? And now I know by the matrix properties, so by the properties, I know that should be A times that first vector plus A times that second vector. But what did we know about those two vectors? We knew that those vectors were both solutions to Ax equals 0. So if I take A and I multiply by either of those vectors, I'm going to get 0. And so what do I get? I guess I get 0 plus 0. And that's 0. Oh man, that shows that this new vector here is going to be a solution to Ax equals 0. Because when I plug it in, I'm going to get 0. So I forgot to put the hat on that 0 vector at the end. But yeah, this is a great application. It shows that basically that solutions to this equation, once we have two solutions, we can add them together and get a third. And if you think about that other property, if I multiply that solution by 5, I'm going to get another solution. I could multiply this by any scalar, and it would still be a solution. And so this is something called a vector space. We're going to see that this is a structure that happens a lot in mathematics, and we're going to study and learn a lot more properties about it. But for now, I will close this video and